Hey team, it's Mr. Z, and today I'm going to show you how to factor each perfect cube. So essentially what we're going to do is we're going to look at this in terms of what would be the cube root of each term. Because if it turns out to be all nice cube roots, then I can apply the strategy. So if I take the cube root of x to the third, that's going to be x to the first. If I take the cube root of 8, that's going to be 2. 2 times 2 times 2 is 8. And then vice versa, if I take the cube root of y to the third, that also comes out to just be y to the first. So essentially with perfect cubes, if you look at the cube root, I know x minus 2y will be a factor. Which means when I divide, the remainder will be 0. So let's go ahead and divide x minus 2y. And let's go ahead and divide x to the third minus 8y to the third. So you're going to ask yourself, how many times does x go into x to the third? And then you're going to say, oh, x squared. And you're going to notice immediately that this first term will become the inverse of it. But after I distribute, it's going to be 2x squared y. So this long division is going to get nasty real quick. So the idea is that in order to use the perfect cubes formula, you identify this first one, and even though you want to do some long division, this problem isn't necessarily one for that. So I highly recommend you use the perfect cube formula. And it's essentially something that's been proven by long division. And essentially, these are the rules. The first one is that when a to the third plus b to the third, it will turn out to be a plus b times a squared minus ab plus b squared. Likewise, a minus b to the third is going to be equal to a minus b with the difference of a squared plus ab plus b squared. So seeing as it's subtraction, and I know that my a term is x and my b is 2y, I can know off of the bat that it's going to turn out to be x minus 2y times my, let me write it out so it's a little easier for you can see, x squared plus x times 2y plus 2y squared. If I clean this up a little bit, the left stays the same. And then on the right, it's going to turn x squared plus 2xy plus 4y squared. If I multiply these two together, it will turn out to be this guy. Likewise, for this other one, I need to factor each perfect cube formula. This is supposed to be a subtraction sign. Sorry, team. So in this next guy, I'm going to go ahead and ask myself, what is A and what is B? Well, A is going to be equal to the cube root of 216 x to the third, and B is going to be the cube root of 125 y to the third power. So you're going to go ahead and figure out, hey, what number times itself 3 times is going to be 216. The same thing goes for 125. You're going to have to ask yourself what number times itself 3 times is going to be 125. Well, the answer is 6x and 5y. So my formula is that it's going to be a minus b times a squared plus ab plus b squared. A is 6x, b is 5y. Next up, I have to do a squared. Well, that means I'm going to have to do 6x times itself plus 6x times 5y plus b squared 5y squared. Now I clean it up a little bit. 6x squared is going to be 36x squared. 6 times 5 is 30xy. And then 5 times 5 is 25y squared. So this isn't necessarily the most intuitive way. The way you get this formula is through long division. You can try it yourself. You can do a to the third plus b to the third divided by a plus b. Likewise, you can do the same thing to discover for the inverse. And there's many resources online, but the idea is that these theorems work without a hitch. So this is just one way to factor some perfect cubes. That's it for now.